Hi everyone, and welcome to our online video series for Integrated Math 3. My name is Dr. Kyle Prince and I will be your teacher for this online video series. Today we're going to talk about a few things. One is mental math, and then secondly is a growth mindset. And then overall we're going to talk about the structure of these video series lessons and what to expect from each one. So what we're going to do is begin today with a warm-up. And so each one of these warm-ups will consist of 6 problems. And I really want to encourage you to try to start thinking about using mental math to solve these problems. I know today is our first time, so if you need to pull out some paper and jot some work down, that's fine. But in the future, we're going to develop some strategies to do some mental math. And I'm not saying that everything needs to be done mentally, but if we have some of the capability to do things mentally, it can really help. And we're going to talk about some of the advantages of having mental math today. So if you would, take a few moments and see if you can solve these 6 problems, and then we'll go from there. All right, so number 1 here, we're just going to go through these. 2 to the 3rd power. When we have an exponent here of 3, which is, if it's a natural number, so if it's 1, 2, 3, 4, so on, so the natural numbers, then we can think of an exponent as just repeated multiplication. So this is 2 times itself 3 times. So 2 times 2 times 2 equals, well, 2 times 2 is 4, times 2 again is 8. With other types of exponents, and we'll get to those in the next few videos, other types of exponents that don't fit into the natural numbers, we have to think about a little bit differently. We can't think of them as repeated multiplication. So we'll get to that here in a bit. Number 2, 75 minus 40. You can either subtract 10 4 times, or you can subtract 70 minus 40 and then add the 5 back in. So either way, we're going to get 35. Number 3, when we're adding fractions or subtracting fractions, I really want you to think about it this way. So each one of these is 50-firsts. So think of 50-firsts as your unit of measurement. Like you have 3 apples plus 4 apples. Apples is your unit of measurement. And so think of 50-firsts or any denominator as your unit of measurement. So in this case, we have 18 50-firsts plus 7 50-firsts plus 2 50-firsts. So 18 of them plus 7 of them plus 2 of them. Let's see, 18 and 7 is 25 plus 2 more is 27. And so we have 27 of them, right? So like 3 apples plus 4 apples is 7 apples. So we have 27 50-firsts. So it's still a unit of measurement, if you can kind of think about that way there. If we don't have a common denominator, then we cannot add them together. Just like adding apples and oranges at that point. And so you have to find some common ground to do that. So that's that one. Number 4, in this case we're solving for n, and one way to do that is to add the left side together. 18 plus 9 is 27, and it equals n minus 2. At this point you can add 2 to both sides, or you can just think about what number minus 2 would be 27. You can just kind of think about it. You don't have to actually continue to solve this out. And that would be 29. 29 minus 2 would give us 27. That would satisfy that equation. The first line is a little bit more difficult to just kind of think about it. So maybe taking that one step further, then pausing and thinking about it. Number 5, there are 6 rows with 8 chairs each. How many total chairs are there? This is the basic definition of multiplication. 6 groups of 8. 6 groups of 8. So multiplication, 6 times 8 is 48. If you think about a similar problem, if we had 8 rows of 6 chairs each, we get the same answer. Because 6 times 8 is the same thing as 8 times 6. And so we have 48 chairs all together. And then number 6 here, simplifying a radical. I really want to encourage you to think about when you get to rewriting radicals like this, is thinking about how to rewrite that number inside as multiplication, in which one of the things that's multiplying is a perfect square. So remember, your perfect squares are 1, 4, 9, 16, 25, 36, 49, 60, 64, and so on. Which of those numbers that I just rattled off there can be multiplied by something in order to get 8? Well, 4 times 2, that's 8, right? So we can rewrite the radical as not the square root of 8, but the square root of 4 times 2. Because we can actually simplify the square root of 4, because we know what that is, right? What number times itself is 4? And that would be 2, right? So we can actually simplify that part of the square root, whereas over here, the square root of 2, we can't simplify that. And so that's going to be left underneath the radical. So when we simplify this, the square root of 4 is 2. Since we've already evaluated the square root, we don't need the square root over top of 4 anymore, because we've already simplified that part, or evaluated that part. Then the square root of 2, this 2 stays underneath. So the square root of 8 is the same thing, or equivalent to 2 on the square root of 2. All right, so hopefully that kind of gives you some help with those problems and gives you a good introduction back into thinking mathematically. So if you're able to use some mental math, that's great. Hopefully next time you'll be able to use some more. But let me give you some reasons why mental math can be really important. One of those is when you're learning math. Mental math can be really important because if you're learning integrated 3 topic and you're stuck on the number manipulation that's involved, you're not going to be able to learn the integrated 3 concept as well. For example, if you're solving something or your teacher's explaining something and there's 3 times 5 involved, and you're thinking about what 3 times 5 is instead of the exponential equation or whatever it is that you're doing. And so you're not stuck on that. Your working memory is able to focus on the integrated 3 concept. Also, calculating tip or sales price. So if you want to leave a tip at a restaurant, we'll do an example, I think next video with 15% and calculating that. I'll give you a little tip there. But anyways, if you are at a store and you want to quickly estimate how much your cost should be, that way when you're checking out, if something's awry, then you can quickly point that out. Sales prices, estimated cost, ACT. So when you're taking your ACT, I know it's a time test, 60 minutes, 60 questions, and just maximizing those 60 minutes. So if I've got a problem and it's 4 times 5, and I've just got to type in 4 times 5 in the calculator just to make sure, that just takes valuable time. But if we can get better at mental math and develop those strategies, then we can trust ourselves and save time that way. And then lastly, number sense and reasoning. Just being able to realize when a calculation is incorrect, just because you have that number sense, but also just applying mental math to any applicable problem or real-world situation. So those are some of the reasons behind mental math. We'll continue to talk about that as we go throughout this video series and continue to use those in our warm-ups as well as during the lessons. So at this time, we'll kind of switch gears a little bit and start talking about a growth mindset. So as you start this online video series and as you begin Integrated 3, I really want you to think about the mindset that you approach mathematics with. And it may change how you think about math and how you've approached math in the past. And so let's go through these real quick. You can learn math. So everyone can be successful in math. There's no such thing as a math gene, or maybe my parents weren't good at math, so I'm not good at math. There's no such thing. You can be successful with effort and believing in yourself. You can do it. There's no such thing as a math person. I already talked about that. Don't compare yourself with others. So faster is not better. When you finish a test, don't think to yourself, "Oh, I was the last one to finish," or if you're stuck on a problem and you're not figuring out right away, that's okay. Faster is not always better. And a lot of times thinking slower and deeper about math is in fact better. And so keep that in mind. Effort, growth, and perseverance are the keys to learning. If you've got that, you can learn math. And so just believe in yourself and you can do it. And you'll find that whatever career you go into, you'll use math in some ways. It may be the mental math that we've been talking about. It may be the algebra. It may be the geometry. and maybe just problem solving in general that you'll use in your career, but you will all use math in some capacity in your career. And then we learn more when we make mistakes than we are successful. So when you mess up, when you make a mistake, just know that you're learning through that process, and we can celebrate our mistakes because that's just an opportunity for us to grow and get better and learn. And so those are some things to think about. But at this time, I'm actually going to turn it over to the folks at Stanford and share a video with you that they've created around growth mindset. Okay, so hopefully you enjoyed that video from Stanford University and their approach to mathematics in terms of the growth mindset. One thing I want to mention before we finish this first video is how people can approach problems in a different way, and how we should appreciate their approach and their solution method. So if you want to just take a second and see if you can think about what would the next step in this pattern be. So we have the first 3 steps. What would the 4th one be? So just take a moment to do that. All right, so you probably thought in a lot of different ways. Let me just give you some examples. So some of you probably just counted 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And then maybe you thought maybe what the next one would be. Others of you may have seen we have 2 plus the 1 in the corner. Here, so we have 1 and 1 plus the 1 in the corner. Here we have a pair of 2s plus the 1 in the corner. Here we have a pair of 3s plus the 1 in the corner. The next one we might have a pair of 4s plus the 1 in the corner, which will give us 9. Others of you might have thought, well, if this is step 1, I've got 1 star at the top here, and then 1 more than that below. So 1 up top, 2 below. Here it's step 2, and then I have 3 below. So it's always 1 more. So we have the step number here, and then 1 more than that down here. So 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5 would be the next one, which will give us 9 again. So that's just an example of something that maybe people might approach in a different way. And we should always encourage our classmates and others that are thinking through problems because their opinion, their solution method should be valued, and we can learn a lot from how other people think about problems. So with that, we'll kind of finish here with the overview of Integrated Math 3. So in the next few videos, we're going to start talking about quadratics, because that's kind of where we left off in Integrated 2, talking about quadratics. And so that's kind of be our bridge between Integrated 2 and Integrated 3. From there, we're going to talk about polynomials in general. So linear functions and quadratic functions are types of polynomials, but we're going to broaden that to include all polynomials. We'll start with that, and then we'll get into some of the algebra behind polynomials. We'll spend some time there. Radical and rational equations and solving those. Exponential functions, and then we're going to introduce you to something new called logarithms, which will be fun when we get there. Then we'll hit some geometry and continue to improve on our geometry skills, including those around coordinate geometry, as well as circles, including the unit circle and some trigonometry. And then we'll finish the year with some statistics. So that concludes our first video in Integrated Math 3. I look forward to diving into some of these concepts with you. And with that, I'll see you next time.